So 17 says limit. And the top is x squared minus x minus 6. Very good. And the denominator is 3x squared plus 5x minus 2 when x approaches negative 2. Awesome. Good. Awesome. Good pick. We are asked to evaluate the limit. What are we going to do first?
I'm just going to plug the -2 in.
Brilliant. Thank you very much. So let's do that. So when we plug in -2, take your time and plug it in. I'm plugging in also. So I have 4 plus 2 is 6. 6 minus 6, I got 0. Correct me if I'm wrong. So this is 12. Minus 2 is 10. And minus 10 is 0. Let me know if you got 0 over 0.
It's indeterminate and undefined.
No, we cannot be indeterminate and undefined. That's not possible.
Not undefined, but
it's an indeterminate case. It's an indeterminate case which has hope. I'm not saying the limit exists. I'm only saying that there is hope. Now, I need to review something very important with you from pre-calculus. So whenever we have a polynomial, so this is a side discussion which is extremely important for these situations. Let's say I have a polynomial p of x. And I plug in 5 and I get 0. What does that mean? Anyone remembers what does this mean? I have a polynomial. I plug in a number, whatever number you want. I said 5, you can say 3, you can say 0, whatever. It doesn't matter. And I get 0. What does that mean? It's okay if you don't remember. So this automatically means that x minus 5, if I had here minus 5, I would have put plus, is a factor of p of x. Another example, so you understand the idea. Let's say I have p of -3. Then what is the factor of p of x if I get p of -3 to be 0?
X plus 3.
X plus 3 is a factor of p of x. So this is a side commentary. This is called the remainder and the factor theorem. If you understood it, that's all we need. Let's come back here. What do you conclude based on our discussion, side discussion? I plugged in -2 at the top and I got 0, and I plugged in -2 at the bottom and I also got 0. What would you tell me about the polynomial at the top as well as the polynomial in the denominator? You will immediately say, so that's how lazy people, I'm kidding. That's how lazy people do it. So I don't want to write this again. I circle or I put a triangle or a rectangle and I jump over this and I continue here. So what will you say? Notice that the limit operator cannot be dropped till the last step. So we plugged in -2, we got 0. We plugged in -2, we got 0. What would you say that I should write top and bottom immediately?
X plus 2.
Exactly. So x plus 2 makes the limit initially be 0 over 0. That's the culprit. That is the problem.
So let me get this straight. That
and now we have to factor the rest. Go ahead.
Okay. No, I was so
let's factor the rest. Let's factor the rest.
Yes.
So can anyone give us the factor at the top and the factor in the denominator?
Top is x minus 3.
Very good. Awesome. Brilliant.
Bottom is 3x minus 1.
3x minus 1. Let's say we want to check, and we should always check. X squared minus x and minus 6. Awesome. 3x squared plus 6x minus 1x minus 2. Awesome. What do you think we're going to do next? Brilliant. Thank you so much.
Should I distribute the limit?
So what do you think we're going to do next? Because we factored. We factored for a reason.
Yeah, it's
So we can eliminate.
Simplify, very good, awesome. Simplify x plus 2, that was the problem. We eliminated the problem. That was our purpose, our hope that we can eliminate the problem. So then limit as x approaches negative 2 from x minus 3 over 3x minus 1. At this point, negative 2 is in the domain of this function, and we have that limit law that says the limit of a rational function is simply determined by plugging it in as long as this number is in its domain. So, can anyone give us the final answer? And now I drop the limit operator. Never before. The numerator will go to
-5.
awesome. The denominator will go to
-7.
-7. So therefore, final answer So one quick analysis here. We started with 0 over 0. I would not believe if anyone would say, oh, I knew the answer was going to be 5 over 7. So the point I'm making is that 0 over 0 can be anything. So it's an indeterminate case. Can it end up being turning into infinity? Yes. DNE? Yes. Anything. When we say anything, we mean anything. Great. Okay.
What if you had applied L'Hopital's rule instead?
Not in chapter 2. 0 credit for L'Hopital's rule in chapter 2. I promise I will not wait till chapter 4 where you see it. I will present it in chapter 3. I promise. You will not have to wait till chapter 4. We are applying the limit laws at this point. But you're right. That you will have to go through a couple of steps for L'Hopital's rule. Good. Moving on. Any questions on this? You can check. If you know L'Hopital's rule, of course, you should check. Other questions?
What does that 5/7 actually represent on your, if you were to be putting a graph or something?
Excellent. The limit of a function means the tendency of a function. As x approaches -2, this function will approach this number.
Okay, so that would be like asymptote or something like that.
It's a number. It's not an asymptote. An asymptote means something else. So an asymptote. So we have different types of asymptotes. So when we determine limit as x approaches 5 from the left, from 1 over x minus 5, we know that this is 1 over 0. 5 from the left will be 4.5. So this will be negative infinity. Therefore, x equals 5 is a vertical asymptote. When we determine horizontal or slant, we are determining limit as x approaches infinity, which we haven't gotten to yet. So if this answer is 5, then y equals 5 is a horizontal asymptote. But we haven't gotten to this yet.
Yeah, but I'm just trying to, I know that you're approaching from either side, you're approaching 5/7, but I'm trying to get it as if, I'm trying to visualize it as if it was on a graph or something.
Yes, it approaches 5 over 7 from either side when x approaches -2. That's correct.
So if you were to put on a number line, everything would be approaching left or right.
The function may be
5/7.
undefined there. It doesn't matter. The limit, it only says that it approaches that number. It doesn't say that the function is defined there. It may or may not be defined. Actually, it's not defined there. Is that what you meant?
I want to pass on right now. and I'm going to throw it into something. Take a look at it. With 573.
So I'm not sure what the question is, but what it means is that from the left and from the right, the function values approach as x approaches -2 from left and right. The function values approach 5 as 7, as we discussed last time. There is nothing else to it. Oh, I'm sorry. I should have. Is it clear? That's all it means. So that's what we discussed last time. Right here.
Okay. Yeah, I think I get it.
So it means that as x approaches 10 from either side, the function values approach 5. In our case, as x approaches -2 from either side, the function values approach 5/7. It's this situation, but with a hole in it. It's exactly what.
Roger, it has a hole. Got it.
Because
I
the
got the
function,
hole.
because that function is undefined, but it doesn't mean that the limit does not exist. We know that they are not the same concept.
No, I understand that there's a hole in it.
Okay. Okay, perfect. So let's continue. I would like to look at a radical situation. So for now, we looked at a rational function. So this is another rational function, is the same thing. This is another rational function, is the same thing. But I like to look at a radical function at this point. And maybe one more. Yes?
Can you briefly talk about what you would do if it has an inverse, raised to an inverse power? So like number 26.
Yeah. So the negative power, all it means, so 2 to -1 only means 1/2. 2 plus h to -1 only means 1/2 plus h.
Okay, thank you.
But we can choose that if that's what you prefer. It doesn't matter. I like to look at a radical function. We can also look at that one for sure. Anyone would like to choose, or I will.
Why don't we do the radical first, and then we can do that one?
Okay, so let's choose a radical.
27.
27, perfect, awesome. 27 is limit as t approaches 0, the square root of 1 plus t minus the square root of 1 minus t divided by t. Perfect. We are asked to determine a limit. What do we do first?
Put the 0 into the.
Awesome, good. We need to identify, because if it happens that this is 4/3, then the answer is 4/3, and we don't have to do anything. That's why we need to plug it in. So can anyone give us where the numerator is going?
The numerator is going to be, it's going to be 0.
Good, and the denominator is 0. So there is hope. There is no guarantee, but there is hope. Good. In this particular situation, the function is a combination of radicals, square root, and a rational function. Any method from the past that will help us now, you think? Anything from your past experience?
I forget the name of it, but
I'll help you with that.
for all of
Numerator.
Excellent. And when we rationalize the numerator or denominator, it doesn't matter. In this case, we need the numerator. We use conjugates. So we are using a very simple formula from algebra. We are using a plus b times a minus b, or reversed, it doesn't matter. Can anyone give us the answer?
Yeah, you multiply the top and bottom
Nope.
by.
Nope, not yet.
conjugate.
First, let's come up with the answer for this. We'll go back to
Okay.
that in a minute.
A squared minus b squared.
Brilliant. That's all I needed for now. So
Yes,
perfect.
you're talking about the top one.
Absolutely, I agree. So now I'm going to multiply, but because I already have the 0/0 and the equal symbol, I will write it again. Okay, but I'm going to write a note here. Multiply by the conjugate, of course, of the numerator, but I'm going to copy it again. So limit as t approaches 0, the square root of 1 plus t minus the square root of 1 minus t divided by t. And this is the formula we are applying. So we need to multiply by, can anyone give us what we multiply and divide by?
Yeah, you would do the square root of 1 plus t plus the square root of 1 minus t.
And the denominator.
Over, and then you do over the square root of 1 plus t.
The same thing, that's all you needed to say.
Yeah, same thing. Yeah.
Very good, awesome, excellent. So then limit as t approaches 0. The denominator is carved in stone. I cannot do anything to it. But now, can anyone give us the numerator? And this is the formula we're using. Please do not distribute or do anything. We are using the formula. I'm ready.
1 plus t plus 1 minus t.
So 1 plus t is correct. Then I have to write minus, and then I have to put parentheses.
One minus t.
I have to show this. Maybe you said it. Did you say minus 1 plus t?
Yes.
No, somebody else before you, Matt.
I don't remember what I said anymore.
Okay, sorry. But I wanted to show where it's coming from. You may have said it correctly, so if I missed something, I apologize. Okay, so now we're going to rewrite it, distributing the -1. Notice that the limit operator does not disappear. If you write this from here, this is incorrect, and you lose a lot of points. So please, the limit operator, the tendency was not applied yet. We did not get there yet. So 1 plus t minus 1 plus t divided by t, the square root of 1 plus t plus the square root of 1 minus t. Before we continue, I forgot to ask you something. I know that this is not a polynomial. This one is. But when we apply t equals 0 in here, we got 0. When we plugged in t in here, we got 0. What do you expect to get rid of? What is the culprit? What is the problem here that we wish it goes away? It would go away.
The radical signs.
So what is the factor that you would wish it would go away?
1/2.
One more time. So let's go back. So when we plugged in 5 and we got 0, then we said x minus 5 is a factor of p of x.
Yeah.
So when we plug in -3, we wrote this. What if I plug in 0 and I get 0? What will be the factor that we are talking about?
T.
Exactly. So t is the culprit. T approaches 0. T is the problem. Okay, so let's see if we can get rid of it. So the limit as t approaches 0, the numerator, 2t over t, the square root of 1 plus t minus, plus 1 minus t. What will be the next step? Definitely, and we are happy about it.
Simplify.
Yes, exactly it. So now we have the limit of 2 over the square root of 1 plus t plus the square root of 1 minus t as t approaches 0. Only at this moment, the limit operator will cease to exist. We are applying the tendency now and we want the final answer. Can anyone give us the final answer for this tendency? Where is the numerator going? Where is the numerator approaching? What is it approaching?
2.
Perfect. Where is the denominator going?
1.
Careful. 1 plus 0 is 1. The square root of 1 is 1.
So
1 minus 0 is 1. The square root of 1 is 1. So the denominator goes to
2.
2. So then the limit or the tendency of the original function, 3 pages, I'm exaggerating, of course, 3 pages ago, where is this tendency? The tendency of this function when t approaches 0 is,
1.
that's it. Okay.